So today I thought I would do something more fun than the stuff I've been doing recently. I needed a little bit of a break from problems and issues with the other projects I'm doing. You know, when you're doing stuff for a while and you just feel like you're getting nowhere, or you're discovering more problems than you're solving. Well, that's kind of how I feel at the moment. So I wanted to do something that was a bit more interesting. So we've got some stuff that's from a post bag that we did ages ago, and these are some little LED lights. They're kind of like fairy lights. They're battery powered. They come in these 3-cell boxes. I've got 2 of them. If I turn one on, you'll see that they're all really nice. They're little SMD LEDs put onto this enameled wire with a bit of hot glue globbed on. In fact, we can probably zoom in and have a quick look at these. So they're quite nicely made. You've got this glob of glue here and the SMD LED in the center. It's sort of blown out a little bit. I can't really see much more of it, but on the back maybe you can see where it's soldered. It's an interesting little thing. And I've also got this glass cloche or cloche. I'm not sure how you meant to say it. It's got a nice, it's got a nice ring to it. So we're going to be using that, and luckily this one came with a base that has a cutout already in it. I assume it's sort of designed for a cable to go in there, but that's not how it was sold to me. It was sold on eBay. You'll have to go looking for it. I don't have a link to it anymore, I don't think, and I'm sure there'll be loads around. It was sort of sold as a figurine holder or for dried flowers, so that might help you out. So we're going to be putting these inside, and I think it's going to look quite nice if they're all sort of moved up inside. You can see there's some nice reflections and things going on in there, so I thought it'd be nice to put those in there, but you know, that's not actually making anything, is it? That's just putting some electrified lights inside a little display. Well, they're getting quite warm. I thought they'd be quite nice if they're PWM'd, so if they're dimmed up and down inside this thing. Maybe we can do that with 2 sets and have them do it like opposite to each other. So that would be fun. So let's try and pen out what we want it to do. So I think we'll probably use an N-channel MOSFET. I've got some BS170s lying around from when we did the ESP8266 outdoor temperature sensor thing. I'm switching that one out, so I can use those. I'm not going to be using them for anything else at the moment. They're in the TO92 package, so they look a little bit like that, and it goes drain, gate, source, like that. Obviously I haven't drawn that in 3D, which would have been nice. But the symbol, I'm terrible at drawing the symbols, so you'll have to forgive me if I'm getting it wrong. But it's essentially that, roughly. And then you've got, so drain is up here, source is down here, and your gate is there. And with the N-channel MOSFETs, to turn them off, you have to ground them out. So we'll be putting on a resistor to ground, probably something like a 10K. And then this will go over to our microcontroller pins. So that'll be our microcontroller just there. So let's figure it out. I think we'll prototype it on an Arduino Uno, and then I'd like to move it over to perhaps an ATtiny85, because they have 2 spare PWM pins. So if we figure out what we want to do, so we're going to have 2 of these sets. And we've got 2 already. The batteries, it requires about, what is that, 4 point... In fact, before we carry on, let's have a look at these on a power supply and see how much current they draw. That'll help us figure out our circuit. Right, so we've got it hooked up to our scope. It's currently set at 4.5 volts, which is going to be the limit for this battery box, pretty much. So if there were 3 AA cells and they're fully charged at 1.5 volts, we'd get 4.5. So let's see what kind of current it would draw at standard voltage. So fairly high, we're looking at 700 milliamps. So it's a lot, but they're very, very bright. They certainly don't need to be that bright. So let's try reducing the voltage. and see if that makes a difference. Let's say we run it off 2 cells. In fact, we can leave it on while we do that. So we take it down to 3 volts. We're still drawing 100 milliamps, and they're very bright still, so it's not a problem. But I don't really want to be drawing 100 milliamps. I'd like it to be a lot less. So what we're going to do instead is I've got a 100 ohm resistor. Let's just focus in on that. So I've got a 100 ohm resistor here, and we're going to try just plugging the positive onto there. So we limit this a little bit with that. So let's just take that off. We'll go back to 4.5 volts. And then we're going to plug this onto that resistor. So we're now drawing 15 milliamps, and they're still relatively bright. That's quite good. It gives us some overhead to play with. We can certainly use PWM with that. We'll start reducing the average current used. I mean, when it's on, it's still going to use 15 milliamps, but average over time, it's going to use less. So they will dim, which will be nice, using that whole persistence of vision dealio. So yeah, quite happy. I think that will be okay. Certainly within the spec of those MOSFETs, certainly better than 800 milliamps. Okay, so we're going to need to have a resistor in line with our LEDs, because they draw a ridiculous amount of current through these batteries. So, well, it's not ridiculous, it's just more than I would like it to run at. So what we're going to need to have is, let's start with our microcontroller. So this is our microcontroller, and then we're going to have power going into there. So that will be 3 AAA batteries, so that's going to be what, 4.5 volts. And then we've got our ground just there, and we're going to have 2 lines coming off here for our PWM. So let's call it PWM1 and PWM2. Now, all we're going to do is replicate this mostly. So we have our drain, gate and source. So this is going to be our gate. So PWM1 is on our gate, and we're going to have it pulled down to ground via a 10K resistor. We've got I'm going to have to draw the whole thing again. This is annoying. I'm terrible at doing the diagrams. I'm pretty sure there's a diode bit in there somewhere just here, but imagine that's there. And then let's draw a little circle around there. And then up here we've got our drain. So that's where our load is. That's where our LEDs are. So if we draw 5 volts up here, not 5 volts, it's 4.5. We'll come down, we'll put a resistor here. So let's use the 100 ohm resistor. And then we've got our string of LEDs. So let's just draw them as one single LED, shall we? And so that's one line, and then this side is to ground. So, and all we need to do is duplicate this twice so that we have PWM1 and PWM2. So it's exactly the same circuit. And we'll need to do that with the Arduino Uno for now. I'll breadboard this up with 2 BS170s. Oh, I should probably mark that on here that that's a BS170. And it's an N-channel MOSFET. So I'll breadboard this up and I'll be right back. Right, so I've knocked it up on a breadboard really quickly, and I've also programmed up this microcontroller. I've dimmed the lights a bit so that you can see the LEDs. I've put a couple of LEDs on here just as temporary visualizers, so without cutting up the other LEDs. And let's have a look what happens. I've just tested it, so hopefully it should be fine when I come to put it on. So I've got 3 batteries here. This is our 4.5 volts. So we'll be seeing if that works. So we've got an LED on, and the other one should be on as well. What have I done wrong here? That shouldn't be over there. It should be there. There we go. So we've got both our LEDs on, and they should fade opposite to each other, essentially. So one will go dim while the other one is bright. So we'll just watch it for a second, because I think I've got it on quite a slow change rate. So I'm using the blink without delay example. So you can see this one's getting dimmer now while this one gets brighter. This one gets so dim that it turns off eventually. And so the delay, or rather the interval, increases the dimmer they are. And then they should switch. So hopefully it should just be like a really slow transition between one being on and the other being on, and one being off and the other being off. So hopefully that's the way it's going to work. You can see this one's getting dimmer now. It's going to be quite slow. It doesn't stay off for a very long period of time, so I might change that. But rather than rip out the wires, because I might do this in another video, because we're getting it's getting quite long, and I need to put it onto some perf boards, so we might go onto that in a minute. But I've got the bare battery box here, and so I can probably, if I've got some clips, I can probably just pull some out. And we've got the lights here, so hopefully you'll be able to see them. So let's take one of these LEDs out of circuit and replace it with one of these. And I'll steal the resistor from there, I think, because I don't think I've got a 100 ohm resistor here, but at 300 ohm might be okay. We'll see. So let's pop that out, and we'll put this one in. So this is the yellow cable going to the power. Plug that onto there, and then I need another one going to the ground on the LED string, and that will go just next to it where the LED was. Now if I plug that onto the ground section, well, I'm not seeing anything. I'm gonna have to go and get a 100 ohm resistor, I think, because this might be limiting the current too much, unless it's off. It was off. So you can see that it's relatively dim right now, but it will be getting brighter as this LED starts to fade. So it does work. They're certainly on. I can prove that by just pulling that wire out. You can see that they actually were on. So once this, in fact, could we reset the microcontroller? Yeah, we can. I think these ones start on as quite bright, so they're not very bright. I'm going to go and get that 100 ohm resistor. Hold on. So here's the 100 ohm resistor. Let's just replace that, and we'll see how much brighter it gets. So we'll reset the microcontroller again, because I know these ones start pretty bright. The lights in here make it seem really dim. Let's just turn that off for a second, and you'll be able to see what's going on. I'll stretch them out a little bit, and hopefully, given enough time, we will see it start to get brighter as the other one gets dimmer. So we're going to sort of just sit and wait for a second. Hopefully you guys don't mind that. So the other LED is starting to get dimmer now, and so these ones will be starting to get brighter. No, sorry, the other way around. So these ones are now going to start getting the brightest they can be as the other LED is now going dimmer. So that's right. So these are getting brighter. It's not very bright. We might have to look at changing the resistor for something like a 50 ohm resistor. So they're the brightest they can be right now, which looks bright to my eyes, not quite to the camera. But the concept is there, so I think that's what we're going to do. So we'll work on the diagram that we've done here, and I'll see if I can sort out a perf board to put this breadboarded version into instead. I didn't have 10k resistors, so we're using 12 point something K resistors. Doesn't really matter, does it? It's just to pull that down, but yeah, hopefully this will work out really nice. Go in this little cloche, and we'll have sort of an a PWM light. It'll be nice, and hopefully we can fit all the circuitry onto the back of the battery box, and that way it will I mean, it could just sit underneath the cloche or just to the side of it, which would be quite nice. Maybe put a little switch on there too. All right, well, I'll see you when I finish this. So probably sometime over the weekend, the coming bank holiday for us, which I'm really looking forward to. All right, bye guys.